A global provider of innovative packaging solutions had a 4-building packaging and warehousing site in the U.S. dedicated to servicing just one of their customers. This customer required that they meet increasing demand while simultaneously reducing operating costs. This site packages and warehouses computer printer equipment. To meet the ever-increasing demands of rapidly changing technology markets, new products requiring new packaging were continually being introduced, on top of the current product line. It was a high-mix, high-volume environment. Additionally, their customer, who funded the facility operations, began requiring quantitative justification for any new capital requests. The project initially involved consolidation from 4 buildings to 3. ProModel was engaged to help them determine if this option was viable. However, soon after the project started, they decided to move to a brand new site with only 2 adjoining buildings, which would reduce costs and simplify logistics. They were not certain if this change left enough space to accommodate required production and warehousing operations. At this point, ProModel's role changed considerably, from simply determining how to conduct operations during and after site consolidation, to one in which an entire new site needed to be designed and moved into without affecting their ability to meet customer deliveries. The ProModel client project team designed a simulation solution to accurately predict key metrics of the proposed new facility operations. The solution used Excel files to interface with a complex model and allowed the client to enter the following key inputs: production schedules, product release and due dates, order quantities and packaging line preferences, truck load and unload times, number of pallets per truck and pallet stacking from the warehouse, equipment downtime, bill of materials of each finished good, and number of resources. The output data from the simulation allowed them to determine the most effective parameters for operating the new facility, such as square footage allocation, proper equipment placement, appropriate racking, location of staged material, number of fork trucks, number of resources. Implementing these parameters as recommended by the project team helped them to increase capacity, improve throughput, gain control over inventory levels, and optimize utilization of packaging lines, fork trucks, and manpower. Additionally, estimated costs for facility relocation, new equipment purchases, and additional storage were all significantly reduced by using the simulation solution to plan for the new facilities. The model continued to provide value even after completion of the initial project. It provided them with an objective tool for quantitatively demonstrating to their customer when new equipment or process changes were necessary, and it was being used as an integral part of their production planning operations. A distribution center for a leading manufacturer of eyewear could only process 70 to 90% of all daily orders on straight time. The company needed to identify and correct the bottleneck causing the delays while keeping costs to a minimum. The layout of the distribution facility consisted of bulk pick areas, carousels, and flow racks, as well as an automatic dispensing system. This layout was inefficient in meeting the total demand of orders, and as a result, they had to run overtime and weekends to meet the demand. Managers also tried to increase staff in different areas of the facility, but were unable to meet their requirements or affect the system throughput. ProModel was engaged to develop a simulation solution in order to help them determine the root cause of their inability to meet customer demand, as well as the necessary implementation needed to increase throughput at minimal or no cost increase. The ProModel solution consisted of 3 separate models. The first model included a CAD layout of the facility and data provided from the warehouse management system that depicted the volume for each order type. The first runs of the model determined that the conveyor system was the bottleneck, limiting the total throughput. Based on this data, managers decided to rearrange the tote introduction areas on the conveyor system and create 2 new tote areas, one at the flow rack and one upstream of the itomatic area. This was tested in the simulation model, and the predicted increase in capacity was only 10%. The model also confirmed a new bottleneck located in the print pack area. It was decided that breaking the print pack area into 2 separate operations would be the best approach to solving the problem. This resulted in a printing order verification area and a packing area. To help determine the best design and throughput capability for the printing stations, a second model was built comparing a single printer station with a double printing station. The results showed a 100% increase in throughput with the double printer station, and the utilization of that operator would be 92% versus a maximum of 46% in the single printer option. The double printer option was selected due to the increase it created in throughput and operator utilization, as well as no additional equipment costs. A third and final model was developed to redesign the facility to allow space for the new printer stations. After running a number of scheduling scenarios, the design was refined to meet future projected demand requirements with a 30% buffer capacity. After implementation, actual operation results were within 5% of the model's predictions, allowing them to meet 100% of their current order requirements on straight time with protective capacity for increased future demand. Excessive overtime labor costs were also significantly reduced. Currently, the model is continuing to be used by the company to help determine the staffing requirements and shift schedules for each area of the distribution center.